The fun continues here on the Astro 30's Electronics Lab. Greetings, the Astro 30 here with another kit to assemble. This one is a miniature DDS, direct digital synthesis, which is basically like a function generator. It uses a large through-hole style processor and an op-amp. Now, there's just going to be one problem with testing this kit. It requires plus minus 12 volt plus 5 volt. So I need to come up with a plus minus 12 volt supply and a plus 5 volt supply at the same time. But I'll cross that bridge when I come to it. Right now I'm going to open the box, the packaging here. Here is our display module. Nice, and it's already got the little processor chips already on there, so you don't have to do too much work getting this thing to work. So everything that drives the LCD is already on the board. Put that to the side. I've got a bunch of resistors all over the place, not actually neatly put in. Here's the circuit board, typical Chinese. It uses an ATmega A16 processor IC. And the interesting thing is they want us to put a 222 picofarad capacitors plus a 16 megahertz crystal inside the IC socket at the same time. Now, with all these kits, they don't come with schematics or any instructions of how to build it. I've looked on the eBay listing for this. There is no like PDF file to download to help you along the way. Now, let's have a look at some parts here. Now, this is nasty. We have an IC socket with half the pins missing, bent to buggery, and I might have to, this looks like this says MH40, so I'm assuming it's a 40 pin. Might have to go out and buy another one because, well, with half the pins missing, it's not going to work. So let's have a look here. What else have we got? We've got the ATmega IC here, but all the pins on that are bent to shit. Yeah, an 8-pin dual inline IC socket. Let me find something to pour the stuff into. Take out what's in there first though. I'll just put them somewhere out of the way. That's better. Right, so here is the ATmega IC. All its pins are all smushed and buggered up. It's not even put into a piece of foam. Very, very bad. So that's going to have to be carefully straightened, and after I solder this together, I'm hoping the fucking thing still works. So what I might do is I might stick that back over here in the anti-static bag to prevent any further damage to it, either via static or things falling on it. Some large BNC connectors, board mounted style, 2 potentiometers. I think they're the same value. No, one's 1K, one's 50K. You got a header pin here plus a matching header socket, which would be for the display module, and they give you an extra 4, I think it is, or is it 3? Only 3. That's interesting. So you cut this down, and it's like you've got 3 over, which don't go anywhere else but go here. So I'm not going to use a header pin for that. That's the +5, +12, -12 ground. Yeah. What we got in resistors? 20Ks, a lot of them. A lot of 10Ks, a couple of hundreds, 100 ohm 12. Yeah, okay. So looking in this parts box, I found a couple of the pins that came out the IC socket. There's 4 missing and I can only find 2 of the pins. So I'm not really sure if I can even reassemble this, but I'll give it a small go. But if it's missing 2 pins, I'm going to have to buy another one. So I'm just basically wasting time here screwing with this. That's one in. Oh, I found 3. So I need another one. I might be able to save the patient. Half these pins are all coming out anyway. So I'll reset that. Oh yes, I found all 4. Yippee-ki-yay, mother! Okay, so I know this is going to be a pretty boring video watching me reassemble an IC socket, but at least all the pins are there, so I don't have to go out and buy a new one. So, and practically speaking, I shouldn't have to, because it should all be, you know, there. So if I grab a pair of pliers and straighten these pins out a bit and give them a slight little tug, as rude as that sounds, just to reset all the pins back where they're supposed to be. Just a note to the person that supplied this kit: put the fucking things in foam. Even if it's not anti-static foam, just put it in foam so it stops this happening. 1, pins bending, and 2, pins falling out. So I'll give them a slight little pull to make sure they're all set in there correctly. And because it's in my hand, this will probably be the first component I solder in. Are you guys bored yet? I know I am. Okay, so they're all reset. I'm just going to make sure they're straight. Or straight enough to get it in the board. That should be it. So, match the notch to the notch. And I'm going to use a screwdriver to set these pins in properly. That's one side in. Ah, there we go. Success. Okay. That one's a little bent. I suppose as long as the IC pin goes in, pins go in there without too much trouble, it'll be alright. So I'll start by soldering that in. One corner. Once I've got this started, I'll mount it in my tool. Make sure that's straight. Yep, straight. Okay. Okay, so I've got it in my tool, and it's mounted in such a way that doesn't interfere with the assembly of anything, so I can just keep it in the tool. Now, I don't think I paid much for this kit. I think it was only like about 11, 12 bucks, something like that. I can't remember offhand. I'll put a link in the description if you want to buy it. But just be aware that he may have the same problem I just did with mushed pins on the IC and the IC sockets related. Haven't seen the op amp. Oh yeah, there's the op amp. All the pins on that are bent to buggery as well. We'll have a look at that op amp in a sec, but I'm just going to get this IC socket installed, plus the 8-pin dual inline one for the op amp. And normally when I assemble a project, I would always start with the IC sockets first. Now that that one's in, this one isn't too bad, it's only just slightly bent. So the notches there. That goes there. It uses an LM358. I can't remember offhand if that's a single or dual op amp. For all intents and purposes right now it doesn't really matter. Okay, that's that IC socket installed. Link straight. Now what I would start with now is all the resistors and get them all in to where they need to go. Just remember there's 4 different values on here, and then we'll move up. But for this connector, what I plan to do, well, I don't have one. I was going to use one of those locking header ones that I usually use for things, a 4-way one. I have to go out and buy one. I've got to buy one anyway. So now it's a interesting matter of doing the resistors, but this LCD here that requires this header, it's going to think about which way I should do this, whether to mount the actual socket on the main board first or mount the actual header on the board. Considering I've got to cut 3 off of this anyway, it's probably easier, because the header just fits in there nicely, is to just solder the header there. So that's exactly what I'm going to do. Just going to hold him as straight as I can whilst I tack one pin in. Check him, and it's crooked. Now it should be straight. Yes, it is. I'll just do the same to the other end whilst holding it, and make sure it's flush with the board. There we go. And then go along and solder it. Also not forgetting to touch up the solder joints for the ends we tacked in. That one's a bit balling. Okay, and that's that soldered in. So now we can move on to our resistors, but there is a little trim pot here which I'm not exactly 100% sure what it adjusts, because it's not marked. It's a 10K, which is a 103, so that's 10 with 3 zeros, making 10,000 ohm, which is 10K. So that can go in that way around, so it's facing out. I think that might actually adjust the DC offset or something, but with no instructions to this, and as to what its actual function is, I don't know. Because there's also 2 board mounted potentiometers, but they are actually marked. One's amplitude, one's offset. So this 1K on the end here is the DC offset. What this is for, I don't know. It might be for LCD contrast, because it is near the header connector for the LCD, and 2 of the pins do actually connect to the header, so I would assume that's what it's for. It's for adjusting the contrast. So that's that soldered in, but it'd be nice if they'd marked it. Okay, moving on. I still don't like that IC socket. Half the pins are still sticking up here. I mean, it'll still work, but that is just piss poor. Absolutely piss poor. Oh well, it is what it is. So I'm going to move on to the resistors next. I'm not going to film everything being soldered in. What's the point? But what I will do is I might piss off down to Jaycar. I've already been out to there once, but I might piss off to Jaycar and I'll get my 4-way connector that I need plus the plug and a 5-volt regulator, because what I'm going to do is I'm going to build up a miniature power supply on breadboard. And actually, out of interest, that plus minus 12 volt rail I believe is only powering the op amp. Now if this is a dual op amp, that means that should be pin 8 is positive, which is yep, and pin 4 is negative. Interesting. Ground should be going to like pin 3 or 2. Interesting. Ground also goes over there. What's that? That's pin 5. That's that's the other side of the op amp. So that must be in inverting mode on that side. But I do believe the 358 is a dual op amp. But yep, there's our plus 12 volt and there's our negative 12 volt. As for where the 5 volt buggers off to, could be anywhere. I don't know the specific data on the actual IC, but yeah, ground and positive 5 volt would go up to here, and the 12 volts just for the op amp. So it'd be very important that we have a good 5 volt rail, at least no higher than 5 volt. Under 5 volt, between 3.6 and 4.8 is good enough. So I'm going to build up a little regulator circuit on a piece of breadboard using two 7812s and one 7805 respectively. Well, not two 7812s, one 7812, one 7912 and one 7805. And I'll probably use a little transistor style, because I don't need 1 amp regulators for that, because it's only no more than 20 mA requirement for that. And these little transistor TO18 style case regulators are good for 150 mA, I believe. So I doubt that either of these ICs are going to draw much more than that, including the LCD, of course. We'll soon find out. But I'm going to go do that, and we'll come back and we'll continue assembly with this. Okay, and I'm back. It's all happening today. I've been out, got some parts. Had to go down to Battery World to get a new battery for the car because that's experiencing problems. And there's people now at the top of the road fixing the water main that's leaking. So it's all happening here. Anyway, I got one of these 4-way connectors. So I might insert him. Should I insert it that way around? No, I'll make pin 1 5 volts, so I'll insert it that way around. That should not interfere with anything. I don't think it will anyway. I should have probably got an angled one. I was going to. But the spaces I've got for mounting the PCB away from the front panel, or from the circuit board here, that should just clear it fine. Okay, I'll stick with that. That's fine. So we solder that in, and then I'll move on to resistortators. I've also got a couple of TO220 regulators for the 12 volt minus 12 volt, and a 78L05 for the 5 volt rail. So anyway, moving on to resistors. If you're unsure what resistors what by reading them, just use a multimeter. Okay, that's all the resistors soldered in. And I might need to tighten the tip on my soldering iron. These have a habit of coming loose, I don't know why. Okay, so having an auto-ranging multimeter helps the situation quite a lot. You don't have to keep switching ranges all the time, which can be slightly annoying, especially if you don't know what the expected value was supposed to be. Just trim off the excess leads, and that's that. That's all the resistors done. Now we can move on to something else. I don't need the multimeter at the moment. So what I might do now is, I ended up with a spare 20k resistor for some reason. Don't know why. So what I might do is these 22 microfarad, 22 picofarad capacitors that go under the IC. I'll try and get them as close to the board as possible. In fact, it might be advisable just to give it a little slight bend over like that, just to make it fit better. There should be another one in here somewhere. Just over now. Oops. Let's touch those joints up. Those two capacitors in. I expect the total assembly time on this to be about an hour. That's better. Okay, yep, they shouldn't interfere with the IC. So next I'll install the crystal, 12 megahertz crystal, which is here. This is actually 16 megahertz. I don't know where I got 12 from. Doesn't matter which way around these go, they're not polarized, and they'll clear the IC body just fine. So I'll put my finger on it whilst doing one side, just to make sure it's flush with the board. Make sure that's going all the way through. Yep. So that's that. Next would be, well, there's only two capacitors left, two 100 nanofarads, 104s. They use monolithic ones. So they can go up the arsehole of that. I hope this video is helping somebody, or is at least semi-entertaining to someone. I'm enjoying building it, yes. It's fairly easy to construct. There's no major gotcha problems with it or anything. Just simply put the parts in where they go, solder them in. If you're not using this type of tool to hold the circuit board in place whilst doing it, I would suggest, like if you're doing it on the desk, I would suggest always starting with the low profile components like the resistors first, then put the IC sockets in, then the header and everything else that's taller. Next are all these tactile switches. There's 5 of them, by the looks of things. No, 6 of them. That one's bent to buggery as well. So 1, 2, 3, 4, oh there's the 6th one, 5, 6. Now there's no polarity to these ones, these are just standard tactile switches. So one goes there. And they're all the same, so it doesn't matter which one goes where. One's bent as well. Geez, people that pack these kits got to be a little bit more careful, I think. This is a pain in my ass. Right, so in order to keep these switches where they are, I'm going to solder one pin from the top just to tack it in place, whichever pin's convenient at the time. Try not touching the end of the switch with the soldering iron like I just did. Won't hurt the switch though. Okay, now solder them in. I wonder how they're going up on the street there with the water main. I don't envy their job. I really don't. I'd hate having to dig around looking for tree roots that have gone through frickin' water pipes and stuff around and try and fix the bastards. Yeah, and that includes digging up concrete and digging up hole and, you know, actually fixing the problem and then mucking around filling it back in. So yeah, I don't envy their job. It's very labour intensive. I mean, albeit they've got all the tools to do it with, but still don't envy their job. I believe that's all soldered in now and all those switches are nice and straight. Yeah, next thing I might mount here are the two pots, and they're bent to buggery as well. Now there's two different ones. There's a 1K and a 50K, and that's this one's a B50K, so that goes there. So unlike my other dedicated DDS, this does not have an electronic amplitude output, so you have absolutely no idea without measuring it what the actual output peak to peak voltage is. So what I'm going to do, I'm going to hold that flush with the board, tack the center pin, do the same over here. Yep, that's tacked enough. They didn't give me any mounting hardware like screws or anything, nuts. That's nice of them. And if anyone knows if there is actually an acrylic case available for this thing to go in, let me know. Because it'd be nice to actually mount it in something. Okay, so those pots are done. Bring the amplitude up a little. I'm not sure where the DC, well, the offset needs to be at the moment without putting it on a scope. Next part to mount are these two BNC sockets. Again, they didn't give me any mounting nuts. I mean, if you're going to supply the part, supply the fucking nut with it. Would be nice. So, these, doesn't matter which one goes in what. And of course I got interrupted with a knock on the front door. They can't find the leak at the moment, so they're going to come back in the next couple of days to fix it. So trying to get this socket to agree with me. That works better. Sort of like I have to get the two rear pins in the holes first and then just rotate the whole assembly until the guide pins, earth pins go in. If I could get the bastard to... Right. Let's make it a bit more heavy, so I'll do that up. So, in order to get this to stay where it is, I'll attack these ground pins, because they're going to take quite a significant amount of heat. At least get them straight in the board. Alright, that should do to start off with. Okay, so I need to trim the ends of those wires off a bit. Okay, and that is the main board potentially assembled. So now all I need to do is, they've given me 4 places to mount standoffs, but only 2 standoffs. That's great, guys. Now the thing with this standoff is, I reckon the clearance issue will be the longest side would have to go through the circuit board, so I'm going to cut the header last 3 pins off. So that would fit in there like that, and then the shorter side would fit in the header, although the top 2 do not screw to the main PCB, and that to me looks way off. There's no way that's going to screw to the main PCB. I might help if I actually plugged it in the right place. That's better. Nope, it's the other way around, you dumb prick. So I'll actually put that in its header. Right. Needs to be a tight fit. Don't do what I just did. Yeah, okay, so I need to put my two standoffs into the upper board. And it might be a good idea now to put the ATmeg IC in, otherwise I'm going to have to pull it back out just to do it. So I'll just finish tightening the screws on this. Okay, okay, put that to the side for a sec. I'll grab my ATmeg IC because now I've got to straighten all the bloody pins on it. Albeit not all of them are bent. And I'm going to have to handle the IC. I've got no choice. That one is really masticated. As I say, packing foam, guys, would have saved me the trouble of having to fuck around doing this. I mean, excuse my French, but I mean, honestly, this is bullshit. Just saying. Oh, that one's still bent out like Leaning Tower of fucking Pisa. Alright, that should be straight enough to get into the socket at least. So make sure we put it the right way around. And now I've got to get this to line up with all the pins in the socket, which may prove challenging because half of them are bent. Now I'm just going to make sure that they're all lining up. And when I push on this, if any pin's bent over and it doesn't work, we'll know why. But it looks like it's in there, nice and straight. So I can attach the top board, and looks like it might need some form of spacer because that's coming at a funny angle. Yeah, probably needs like half a dozen washers on there. What a pain. I believe that's all the way down. Yeah, and those processors are in really close contact with the main processor. So what I want to do is actually install the op amp as well, because the main board, top board covers it, excuse me. Straighten that pin. Straighten those pins. Put that right way around. I can't believe it. This whole video I haven't farted once. Now, having said that, there's probably one coming. Right, that's in there. Now to sort out what to do with this. I could use an M3 nut actually, but then if I do that, I won't be able to get it tight into this unless penis. Okay, so I've got two M3 nuts. Well, I did have two M3 nuts. There it is. That should give me the right height that I need. I mean, they could have just used, you know, the correct that is probably too high now. Okay, wash as it is. So I don't know how much height I need, so I'll just start with 2. On either side and see if that gets us relatively straight. The problem is it's leaning down at an angle, so it's not sitting up straight, as it should. So I'll do for a test. I reckon that's going to be as close as I'm going to get it. So I'm going to go with that, which is now going to be awkward trying to get the screw to go through both of these washers at the same time. That one's fine, so I'll get him started. It's this one that's moved. Okay, shift him down a bit. Now, see if I can get this. There we go. That's what I want. Oh, just lost the other side, but that's alright, I'll get this one started first. Right, now I'll sort out the one that just fell out. Hopefully this doesn't have to come back off again, but at least it unplugs, so it won't be too much of an issue. That is way off. One does up, one's not. It's because the washers are off, you idiots. I put the washers in the wrong place, didn't I? They're nowhere near the hole. Well, I thought I was going crazy there for a minute. Because I know it fit up the first time, why doesn't it fit now? Because you can't line shit up, dude. Alright, get that one, and now I can do them up. Don't have to over tighten. Yes, the washers hang off the edge of the board. Is it an issue? No. As long as it keeps the display board at the correct angle, whatever works, yeah? So next it's time to solder these pins to connect the main board to the display board. Now this will be single-sided, so, and this, in my honest opinion, is the easiest way to solder a header to another board that interconnects with another one, is to put it in the header and just line the two boards up and solder it. Alright, so that's the LCD driver board / LCD display module installed. I'm going to leave the piece of plastic over the LCD there on until after I finish testing it. So now I've got that display, that contrast pot, whatever it is, in the center. The amplitude's up a little, offset's up a little. I think there's a HS out and a DDS out. The DDS out's here on the right. I think it's the HS out we use. I'm not 100% sure at the moment, but I'm going to need a power supply for it. So that's the next task, is to make up a power supply. I've got a 30 volt center tapped 150 mA transformer. Catalog number is MM2007. So that should be in more than enough current there. I've got the regulators. I've got a little button bridge rectifier. I've got everything I need. I've got some capacitors. I'm going to use two 4700 microfarad 35 volts overkill, but it'll do. And because I'm using TO220 regulators style casing, they're not going to fit in breadboards, so I might just do point-to-point wiring. Anyhow, I'll figure out something. That's the next step. But right now I'm going to have a break. Alright, I did think of building a whole complete power supply point-to-point. I'm going to make a circuit board later, but I thought, what's the point when I can use the power supply, which is off to the left here, set at 12 plus minus there, and just use the 78L05 on the breadboard there to get the 5 volt rail, and then just jam the pins of the connector of the wire there into it. Hopefully they stay there and they're making good contact. We'll soon find out. So before I connect anything to the module, it's not plugged in at the moment, I'm going to first turn the load on and make sure it doesn't go bang. Nope, there's no excessive current draw either. Just want to verify what the voltage output at the 5-volt regulator is. 12 volts, that's concerning. Okay, so either I've wired it wrong or the regulator doesn't work. Yeah, right. That regulator don't appear to work. There should only be 5 volts there. Take that capacitor out. No, I can't get 5 volts out of it. Alright, let me just confirm that I've got the correct pin out for the correct device. Fucking nice. Well, apparently there's actually 2 pin outs, one in reverse, one the other way, that I've got it now. So if I reverse this around in the breadboard here and try it again, no excessive current draw. Now we've got 5 volts. Yep, it's the other way around. So instead of pin 1 being the input, pin 3 is the input, and the output is pin 1 conversely. So I'll just stick this bypass cap back in there if I can. That's why it's always good to verify what the output is first before connecting it to a circuit, because you can blow it up. So we've got 6 volts, that should be fine. We should have plus 12 volts here. Close enough. And we should have negative 12 volts at this connector. Yep, close enough. One's slightly higher than the other. Okay, so now I can connect it up to the module and we'll see if we have any life. Okay, so this is the first attempt. Nothing's going to blow up. Well, we've got a display lit there. That's about it though. So the display's lit, but there's no text. So just make sure that this contrast is set correctly. There we go. Now it's got a display. So we're currently at 100 Hertz. Sorry, 1000 Hertz. That turns it on, that turns it off. Okay, so that's left, turns it up, turns it down. Okay, so what does that do? Square wave, triangle, sawtooth, reverse sawtooth, ECG, whatever that is, I can't remember offhand. Frequency step, 100 Hertz. Noise, random off. High speed, 1 megahertz. We'll do it on sign, so I need to turn that off and hook it up to an oscilloscope. Cunt. Am I still recording? Yeah, I just said cunt. I just said cunt again. Oops, sorry. I just said cunt. Would you stop coughing, you motherfucker? Okay, so I basically got everything set up. Got the little DSO sitting here. Don't know whether you could see that, but I can turn that on now. Press start. Don't see any output yet. Yeah, well that's interesting. So it must not be the HS output. It must be the DDS output. So I'll switch the outputs around. Okay, still going. There we go, we've got an output now. I've got a voltage peak to peak of 8 volt. So let's put that to 1 volt per division. There's our 1 volt. So as we can see, the sine wave is fairly clean. Okay, so we change our frequency . 2 kilohertz. And it says 2 kilohertz on the DSO, so all well and good. There we go, so the module's working. So now let's find out what its maximum peak-to-peak output is if before any distortion, which is right there. So before distortion we are pushing, actually I might go back to 1 Hertz so I can see it better. 12.16 volt peak to peak roughly, and into distortion no more than that. So yeah, you can get a good 12 volt peak to peak out of the output of this, so that should be all well and good. So having done that, I can turn that off and fix up the solder on joint on the switch, and that's not even getting hot, so it's no great issue. So at some point I will revisit this this little project and make a power supply for it. But that'll be a topic of another video. Don't know if that did anything. Whoops. Oh, that's stuck. I just touched the wire insulation here on the power supply to the DSO. Anyway, so that's a bit straighter. But if anyone knows of a case for this, that'd be great. Leave your comments and thoughts down below. I think I did mention at the start of this video, I'd put a link in the description to where I got this and how much exactly it cost. I think it might have been more on the order of 20 bucks, I can't remember. Anyhow, it's working, works first time. That little pot just adjusts the contrast of the text on the LCD, not the brightness, so that's fine, you just adjust it so it's readable. If you stick it in the center and you turn it on and you see nothing but the blue background, turn that pot. I turned it clockwise, about quarter of a turn. So there you go, that's this little mini DDS built, working perfectos, and yeah, I hope you enjoyed this video. If you did, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying see ya, happy DDS.